bracket, it's going to be cosine theta plus n pi, plus k 2 pi divided by n plus an I of sine theta plus 2 pi k divided by n. In such a problem, you have, or in this problem, you have n which is 5, L k, it's going to be 0 or 1 or 2 or 3 or 4, those are 5 roots. The main problem is to identify the value of theta and the value of r, and this is really simply can be done easily by remembering that this is the x-axis. We are measuring our angles from the positive side of the x-axis, so I will go for 180 from the positive side of the x-axis. And this way, this is x, so 180 in order to get to negative 32. So r simply is going to be the square root of negative 32 to the power of 2 plus 0, which is going to be 32. Theta is going to be pi, so simply z will equal to 32 to the power of 1 over 5, open your bracket, and this is going to be cosine of pi plus 0 or plus k times 2 pi over 5 plus I sine, as I told you, pi plus 2 pi k over 5. The k's should be equal to 0, then k equal to 1, then k equal to 2, then k equal to 3, then k equal to 4. Start substituting, so simply z will equal to 2. 32 to the power of 1 over 5 is going to be 2. Open your bracket, cosine pi, which is cosine 180, cosine pi over 5, plus I times sine pi over 5. For the second one, it's going to be 2, cosine, which is going to be cosine 3 pi over 5 plus I sine 3 pi over 5, and so on. For the rest of it, I will get the 5 roots for this value, and so I will be able to evaluate z equal to 5. We will have similar problems in our main lectures. He simply is asking you about the value of z to the power of 6 for that 1 plus 2 plus I for 1 minus 2i, which is also very simple problem, really very simple problem. All I have to do is to simplify. First, the part inside, that's z, which equal to 2 plus I over 1 minus 2i. Simply multiply, and the conjugate of the denominator, 1 plus 2i, you will end up having 5 in the denominator. For the denominator, it's going to be 1 times 2, which is 2, then 2i, they will, so it's going to be 2, then negative 2, then you will have I plus 4, okay, 5i, so you will end up having I, this is the value of z. If you want to get the value of z to the power of 6, so it's I to the power of 6, which is simply I to the power of 4 times I to the power of 2, you will end up having negative 1 for this problem. Really very simple, nothing much. You had to find the conjugate, get the multiplication, then the substitution, very simple problem. Unfortunately, some of you didn't solve this problem, but please do review the complex problem. I believe this is the final problem. You will have Cramer method. I've already stated a previous problem on Cramer method. First of all, you will have to rearrange your matrix form. So simply, all I have to do is to rearrange this system and put it on a matrix form. So simply, it can be on this form: 10 for x1, then I will have negative 3x1, then I will have 5, then for x2 we have negative 7, this is going to be positive 2, then negative 1. For x3 it will start with 0, then 6, then 5. This is the main matrix, the coefficient matrix. I will have x1, x2, x3 for the unknowns, and then finally I will have the result, which is 7, 4, and 6. Simply, I can get the values. So he's asking you about a solution using common method. So x1, x2, x3, and for x1, all I have to do is to get the coefficient, determinant of the coefficient matrix, then the determinant of x1, here's the determinant of x2 divided by the coefficient matrix. Similar manner for dx3 divided by the determinant of the coefficient matrix. Please review this part. It's really very simple. It's all you have to do is to about this part in algebra, which is dealing with the system of equation. Really very simple part. Please go through it. You have the elimination, the Cramer method, and the Gauss-Jordan, but simplest is Cramer, especially when you are dealing with 3 by 3. All I have to do is to evaluate the denominator. I'm going to write one for you. You have problems, a lot of problems like this. Try to go and solve one of them. This is the main determinant, which is 10, negative 3, 5, negative 7, 2, negative 1, 0, 6, and 5. And for the determinant of x1, I'm going to replace the column of x1 by the result column, which is 7, 4, and 6. Then the remaining, it will stay the same. So negative 7, 2, negative 1, 0, 6, and 5. And this is going to be 0, 155. Similar manner for the second and for the third. All I have to do, the only change is I'm going to replace the second column by 7, 4, 6. And here the third column will be replaced by 7, 4, and 6. Already in the previous bit, I've already solved a problem like this in the previous video. So just watch it. I believe by this problem, it will come to the end of our revision for today. In the previous lecture, I've solved problems on the ordinary differential equation, higher differential equations. Please go through them. You have the main video or the main lecture for these problems. I made a revision previously on them before your classwork too. Also, before starting this series of lectures, reviewing everything that we did go through, I've started on solving those problems which came in the first exam. Study the application, it's very, very important. It's an elective in the RC or the RL circuit. Please, I want you to go through it. And with my all best wishes for you always success. Wish you the best. Enjoy it, and please feel free if you have any questions to contact me through email or through chat or through your student trips, whatever. I'm here for you. We are all here for you. I'm trying to make your life easier and your educational experiment more faithful. Thank you very much. Enjoy. Bye-bye.